Hey guys, what's up? This is Salem, and today we will explore 3 deep facts about the universe. Number 1, it is the same everywhere. This is something that will either be surprising to you or obvious. For me, it was very suspicious. I was very suspicious when I heard this, that the universe is the same everywhere. That if you take the solar system and you put it on a faraway galaxy, you will not tell the difference. How can you know that? How can you know that the rules are the same everywhere in the universe? We haven't been there, and most of the things that are there never reach us. But there is one thing that reaches from faraway places, and that's light. And so if you look at the structure of that light, you will notice that it was probably emitted by the same sources that happen here on Earth. So let's say you take hydrogen or helium or some atom here on Earth and you study it. You look at light that comes to you from that atom. And you see that that light has a certain wavelength and it has a certain structure to it. And so you conclude that when I look at the stars, I see light. And when I look at the structure of that light, I notice that it is the same as the ones that we produce here on Earth. So probably the rules there are the same. At least the rules of light and how light is emitted from atoms. But that is a result of the rules of electricity and magnetism, which produce light in the first place. Electricity and magnetism basically explains everything that we see here on Earth. So atoms and everything that you see are basically a result of the interactions of electricity and magnetism. And so if that's the same, then probably everything else is the same. Because the two main forces controlling our life is electricity and magnetism plus gravity. We can also look at the galaxies out there and see that gravity is probably the same. But of course, with gravity it's a little bit more complicated because of dark matter. When you look at Earth and you study gravity between Earth and myself or Earth and the Sun, you conclude a law for gravity. But when you assume that law and you look out into the galaxy or into faraway galaxies, you notice that either the law is the same, but there's some extra mass that we don't know, and that extra mass you can call dark matter, or the law itself is different in other places, and that's why it appears to be different when we look at these galaxies. Dark matter can be explained as a difference in the law of gravitation from here and when you compare that to other places. But there's also clever ways that you can conclude that that's probably not the explanation. If you look at two things far away that are colliding, you can see that a lot of the matter that is involved in the collision just goes through each other. And that thing that goes through each other is called dark matter. So this is this is a story for a different time. Dark matter, I'll talk about it later. You can look up the experiment on the bullet cluster if you want to learn more. Let's move on to number 2. Number 2, atoms were created in the first second. This is one of the really cool stories in the Big Bang. So you probably know the word the Big Bang Theory, and you know that it relates to how the universe started. So this Big Bang Theory tells you that the universe started in a very hot, dense state. Everything was very hot. The entire known universe was very compressed into a very small region. It was very hot and very dense. And in that hot, dense gas, things were hitting each other, colliding, and other products were coming, so you had a lot of collisions. And again, with this, we start to wonder, how do you know that? We were never there. What survived to us that makes us think that that was probably true? One of my favorite pieces of evidence, and my favorite pieces of evidence in science in general, is how we know that the Big Bang Theory is true. And it also relates to how even the atoms that we are made of, you probably heard that the atoms that we are made of happened inside the stars. But before even that, hydrogen and helium were created during the Big Bang. So before, let's say in the very, very early universe, there was some gas, and that gas was filled with particles that we don't know. We don't understand yet, and it was very high energy, so there are things that we don't even produce right now. But then as it cooled down a little bit, these pieces started to collide and produce the atoms that we know. And the atoms that we know, like hydrogen and helium, and that are composed of protons and neutrons, that when they hit each other, we can study here on Earth what happens when they collide and something comes out. For example, two hydrogens hit each other, or four hydrogens hit each other, and as a result comes out helium. So you can study this dynamic of this process on Earth by just bringing things together and colliding them. And after you can understand this process, you can try to calculate what would happen if the universe really started in this hot, dense state, and things were really colliding each other when they were compressed and expanding. And so you conclude with that after you do the calculation, maybe you run it on a computer, and from there they got a number for the difference between hydrogen and helium ratio. So maybe 70% hydrogen and 20% helium, something like that. And then again, we look out into the stars and different dust that you see around the universe, and you say how much fraction of that is helium and how much of that is hydrogen. And the way that you can calculate that fraction, again, remember, we're getting light from there, and we can analyze the structure of that light and try to deduce how much of that came from hydrogen and how much of that came from helium. So amazingly, you look out into the sky and you find that the relative abundances between hydrogen and helium are actually what you predicted. And that's really amazing. It just always amazes me that we can really know something like that. Number 3, we were all inflatons. What does that mean? You probably never heard of an inflaton or the inflation field. And this is something that is probably true or probably existed in the early universe. And it's the form of matter that made the universe expand really, really fast. And people sometimes say that this form of matter is what set the Big Bang into motion, because that inflation matter, or inflaton matter, let's call it, has the property that it tends to expand space exponentially. So when it was present in the beginning of the universe, and according to some of the best theories that we have, that it was really present, and so let's assume that it was present in the Big Bang, in the early Big Bang, it caused the universe to start. And that fast expansion, coupled to quantum fluctuations, expanded really, really fast, and these quantum fluctuations that came in and out of existence, because you stretched them out immediately, that resulted in a little bit more matter here, a little bit less matter here, and amazingly that differences in matter came from quantum mechanics. And that little differences in matter, with time, kept growing and growing until they became you and me. They formed galaxies and stars and everything. So according to this theory, amazingly, we were quantum fluctuations in the background. We were quantum fluctuations in empty space that grew really fast. And that's really amazing. Like, you think of yourself as a human, but you are also part of the universe, and your history is part of the entire universe. So this inflation field that you probably never heard about and is very hard to understand is actually what you are made of, or what eventually created you. So back then, you were an inflaton, or you were as potential in an inflaton. The inflaton was something that grew to be you. And it's not important for you to know what an inflaton is, but you are part of the universe. When the Earth was just a cloud of dust, you were somehow in it. And that thing, that dust, is the same thing as you. So when you look outside and you see just dirt, or you see dust in the sky, don't think lowly of that, because in that dust, something like you can emerge. And it's really amazing that we are basically quantum fluctuations that grew really fast and eventually grew to be humans. So this is a beautiful thought. You should feel connected to the universe and not something that is stranger in the universe. Okay, so thank you for watching, and I will see you guys next time.